Hi everyone, welcome to our physics class. In the previous class, we have studied about some basic terms, that is mechanics. What is the meaning of mechanics? Mechanics is the study of motion or states of material particles under the action of force. Mechanics is mainly divided into two branches. One is statics and another one is dynamics, right? So what is the meaning of statics? Statics deals with the study of objects at rest. When the object is said to be at rest, the object does not change its position with respect to its surroundings. So what is the meaning of dynamics? Dynamics deals with the study of objects in motion. So when the objects are said to be in motion, the object changes its position with respect to its surroundings. Actually, dynamics is further divided into two types. One is kinematics and another one is dynamics itself. What is the meaning of kinematics? Kinematics is the study of motion of objects without considering the causes of motion. Dynamics deals with the study of objects taking into consideration the causes of motion. So depending upon number of coordinates, number of directions needed to specify the position of object. So motion is divided into three types: motion in one dimension, motion in two dimension, motion in three dimension. So if a particle moving along a straight line, then the motion is said to be one dimensional. If a particle moving along a plane, then the motion is said to be two dimensional. If a particle moving in space, then the motion is said to be three dimensional. So this is motion along a straight line part 2. So let us start today's class. So first let us discuss about distance or path length. So what is the meaning of distance? So distance is very simple. Distance is a physical quantity. Actually, distance is a scalar. What is the meaning of quantity? Quantity means anything that can be measured. Anything that can be measured is called a quantity. We can measure a quantity with certain instrument, that is called physical quantity. So distance is the length of a path covered by a particle in certain time without considering direction. What is the meaning of distance? Distance means the length of a path covered by a particle in certain time without considering the direction. Distance is a scalar physical quantity. Distance having only magnitude, doesn't have any particular direction. Okay, what is the meaning of distance? Distance means the length of total path covered by a particle in a certain time without considering the direction. Okay, and the next very important term, that is the displacement. Displacement is the shortest distance between the initial and final position. Okay, so here first let us consider a particle that is traveling from P to traveling from P to Q through R. Particle traveling from P to Q, P to Q through R. So in this case, the distance, total distance traveled by particle is PR, PR plus R cube. Is it not? This is the total distance traveled by a particle, because here this is initial position of the particle and this one is the final position of the particle. Okay, what is the meaning of distance? Distance means the length of total length of path covered by a particle. Total length of path covered by a particle in certain time, but without considering direction. But the displacement, what is the meaning of displacement? Displacement is the shortest distance between initial and final position. Okay, so here the shortest distance between the initial and final position is PQ. Is it not? So PQ is the displacement, PR plus RQ. So this is the path length. Okay, so now let us discuss about other examples. That is when a particle or when a ball is thrown vertically upwards, when a ball is thrown vertically upwards and caught back by the thrower, when a ball is thrown vertically upwards and caught back by the thrower. In this case, so h is the height reached by the ball. So total distance traveled by the ball is h plus h. What is the meaning of distance? The path, length of path covered by a ball. Okay. What about the displacement? Displacement, actually here displacement is equal to 0. So what is the meaning of displacement? Displacement is the shortest distance between initial and final position. Actually here the initial and final position of the ball is same. Okay, so that is why the displacement is equal to 0. This is another example. This is the first example. This is the second example. The first example, what is the total distance? Total distance traveled by a particle is PR plus RQ. And what is the displacement here? Displacement, that is PQ, right? So in the second example, distance is h plus h to h, displacement is equal to 0. Okay. So this is the next example. So when a ball is thrown vertically upwards, ball is thrown vertically upwards from the top of a tower. Okay, so let the ball reaches the bottom of a tower. So this is the example. So in this case, what is the total distance traveled by the ball? The ball is thrown vertically upwards from the top of a tower. Okay, so let us consider the path is A, B, and C. So B is the maximum height reached by the ball. So let us consider AB height is small h and height of the tower is capital H. Okay, right? What is the meaning of distance or path length? Distance or path length is length, the length of total path, the length of total path covered by the particle at a certain time without considering the direction. So here total path length is AB plus BC, right? So AB value is how much? H, small h. BC value, small h plus capital H. BC is small h plus capital H, right? So the total path length here is 2h plus h. So what about displacement? So displacement is the shortest distance between the initial and final position. Okay. So here the vertical direction that is taken as positive and vertically downward direction, vertically upward direction that is taken as positive, vertically downward direction that is taken as negative. Okay. So displacement is h minus of h plus h. Okay. So finally we will get h minus capital H. So h get cancels. So this is equal to minus capital H. So here the displacement is negative, right? So this is the capital H is the shortest distance between the initial and final position of the ball. Okay, let's move to the next example. So when a particle traveling from A to C through B. Okay, so A to B distance is 4 meter, B to C distance is 3 meter. So in this example, what is the total distance traveled by the particle? So here, the distance traveled is AB, right? AB plus BC. So AB is 4 meter, BC is 3 meter, right? So total distance traveled by the particle is 7 meter. So this is very simple calculation, but displacement 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 is not equal to 7 meter, right? Displacement is the shortest distance between the initial and final position. So AC is the displacement. So that can be calculated by using a theorem. What is that? Pythagoras theorem. So your AC value is root AB square plus BC square. That means 4 square plus 3 square. Root 16. What is this? AC. Root 4 square, that is 16, plus root 4 square is 16, plus 3 square, that is 9. So root 16 plus 9, that is 25. Root 25 is 5 meter. What is this? Displacement. Okay. So in this case, distance traveled by particle is 7 meter. Displacement is 5 meter. Okay. So the next example. Suppose if a particle completes one rotation in a circular path. The particle completes one rotation in a circular path of radius is small r. So in this case, what is the path length? Distance traveled by particle. The particle completes one rotation, total distance traveled, that is exactly equal to circumference. Is it not? That is 2 pi r. So this is the distance traveled by the particle. So what about the displacement? Displacement actually that is 0. Okay. Because if a particle completes one rotation, the initial and final position both are same. That is why displacement is equal to 0. Okay. So the next example. If a particle completes half rotation, Look at this diagram. A particle completes off rotation. Okay. So in this case, the distance, total distance traveled by the particle is 2 pi r divided by 2. That is pi r, right? And the displacement is, this is the center. Let us consider this one as O, or is the radius. So A is the initial position and B is the final position. So what is the displacement here? Displacement is AB. AB is OA plus OB, that is R plus R to R. So this is the displacement. Okay. So the next example. Suppose if a particle completes 1/4 the rotation. The particle completes 1/4 rotation. So in this case, what is the distance traveled by the particle? Okay, that is pi r divided by 2, right? So this is pi r divided by 2. The particle completes off rotation, distance traveled is pi r. So if the particle completes 1/4 rotation, the distance traveled is half of pi r, right? And what about displacement? Displacement is the shortest distance between the initial and final position. So A is the initial position. Okay, B is the final position. Here, the shortest distance between A and B is called AB. Okay, so here O is the center of the circular path or is the radius. Actually, we have to calculate the displacement, that is AB. So AB is equal to, what do you find out AB? By using Pythagoras theorem. AB is equal to root r square plus r square. That is the root 2 times r square. So root 2 into root r square. So square root get cancelled. Finally, we will get root 2r. What is this? Displacement. Okay, so what is the meaning of distance? Distance means the length of path covered by a particle, length of total path covered by a particle in a certain time without considering the direction. So distance is which type of physical quantity? Actually, distance is a scalar. Distance is a scalar physical quantity. What is the meaning of quantity? Quantity means anything that can be measured. Anything that can be measured is called a quantity. So distance is a physical quantity. What is the meaning of physical quantity? What is the meaning of physical quantity? If we can measure a quantity with certain instrument, that is called a physical quantity. Okay, anything that can be measured is a quantity. If we can measure a quantity with certain instrument, that is physical quantity. Actually, all physical quantities are classified into two types. One is scalar physical quantity and another one is vector physical quantity. So distance is your scalar physical quantity. Displacement, and this is a vector, because displacement having both magnitude and also direction. Can the distance be negative? No. Answer is no. Distance is always positive. Distance can never be negative. Can the displacement be negative? Yes. Answer is yes. Right? Displacement can be negative. Displacement can be positive or negative or zero. Okay. So what are the differences between distance and displacement? So that is very, very important. The differences between distance, differences between distance and displacement. So the first difference is the definition. What is the meaning of distance? The length of total path. The length of total path covered by particle in certain time without considering the direction. The length of total path covered by particle in certain time without considering the direction. Displacement is the shortest distance between initial and final position. Okay, the distance is a scalar. Distance is a scalar physical quantity. Displacement is vector. Displacement is vector physical quantity. So distance is always positive. Displacement can be positive or negative. Displacement can be positive or negative or zero. But distance is always positive. So these are the some very important differences between distance and displacement. Distance having only magnitude, displacement having both magnitude and also the direction. Okay. So these are the differences between distance and displacement. Okay. The next topic is speed. So what is the meaning of speed? Speed means simply distance covered divided by time taken. Speed is distance covered per unit time. Okay. What is the meaning of speed? Speed is the per distance covered per unit time, or the time rate of change of position without considering the direction. Time rate of change of position without considering the direction, that is also called speed. Okay. Speed is measured in terms of meter per second. The distance is measured in terms of meter. Time is measured in terms of second. So meter per second. So this is the SI unit of speed. And speed is a scalar physical quantity. Speed is a scalar. So speed is a scalar physical quantity because speed having only magnitude doesn't have any particular direction. So name the instrument that can be used to determine the speed of the moving object. What is that? That is speedometer. Okay, speedometer. This is an instrument used to measure the speed of the moving object. Speedometer is an instrument used to measure the speed of the moving object. Okay, so speed is mainly four different types. One is average speed, another one is uniform speed, and non-uniform speed, and instantaneous speed. Okay, so the first type of speed, that is average speed. Suppose if a particle covers distances is x1, x2, x3 in time t1, t2, t3 seconds. So in this case, what is the average speed? The average speed, actually, average speed, V bar. So this is a symbolic representation of average speed. Average speed is the ratio of total distance traveled by particle divided by total time taken. So here total distance traveled by particle is x1 plus x2 plus x3, right? Total time taken t1 plus t2 plus t. Okay, total distance traveled divided by total time taken. The ratio of total distance traveled divided by total time taken. So this is average speed. Okay, the next one is uniform speed. Uniform speed. So when a particle is said to be moving with uniform speed. Okay, first here let us consider a graph, xt graph, distance versus time graph. So xt graph means distance is taken along y-axis. The distance is measured in terms of meter. So time is measured in terms of second. Okay. So if a particle covers 1 meter distance in 1 second. Okay. So in this graph, the point is 1, 1, right? If a particle covers 2 meter distance in 2 seconds. What is the point? The point is 2, 2. Okay. If a particle covers 3 meter distance in 3 seconds. So here the point is 3, 3. If a particle covers 4 meter distance in 4 seconds. So the point is 4, 4. Actually, this is the uniform speed. So when a particle is said to be moving with uniform speed, it is very simple definition. If a particle covers equal distances in equal intervals of time. Okay, if a particle covers, look at this graph, if a particle covers equal distances, right? Equal distances, that is in equal intervals of time. Okay, particle covers equal distances and equal intervals of time. So actually, that is uniform speed. So when a particle is said to be moving with uniform speed, the particle covers equal distances in equal intervals of time. So what is the meaning of non-uniform speed? Non-uniform speed. If a particle covers unequal distances in equal intervals of time. If a particle covers unequal distances in equal intervals of time, or equal distances in unequal intervals of time, or unequal distances in unequal intervals of time. That is actually non-uniform speed. And the last one, that is instantaneous. 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 Instantaneous speed. So instantaneous speed mathematical expression is V is equal to limit of delta t tends to 0 delta x divided by delta t. So or simply dx divided by dt. Okay, so this is the mathematical expression for the instantaneous speed. So instantaneous speed means speed of a particle at one particular instant of time. It is very simple. Okay, the speed of a particle at one particular instant of time is called the instantaneous speed. Okay, what is the meaning of speed? Speed means distance covered divided by unit time. Distance covered per unit time, or the time rate of change of position, without considering the direction. Speed is which type of physical quantity? Speed is a scalar physical quantity. So the instrument used to measure speed of moving object, that is speedometer. Speedometer, so that is an instrument used to measure speed of the moving object. So these are different types of speed. First one is average speed. Average speed is the ratio of total distance traveled by particle to the total time taken. So when a particle is said to be moving with uniform speed, a particle covers equal distances in equal intervals of time. So when a particle is said to be moving with non-uniform speed, if a particle covers unequal distances in equal intervals of time, or equal distances in unequal intervals of time, or unequal distances in equal intervals of time. So what is the meaning of instantaneous speed? The speed of a particle at one particular instant. Okay, speed of a particle at one particular instant is called the instantaneous speed. Okay, thank you.